Got a couple of complex numbers. We've given what Z1 is and Z2 involves an unknown. Asked to express Z1 in modulus argument form. So I'm just going to draw it on an Argand diagram. And it's 2 minus 3i. So that means I'm going to be positive for the real axis, but actually negative for the imaginary. It's going to look something like that. Going along 2 and down 3. So for my modulus of Z1, it's just the length of that line. And I can use Pythagoras, 2 squared plus 3 squared, you can ignore the minus, square rooted, 4 plus 9, root 13. That's my modulus. And then the arguments, well, let's find theta. So tan theta is going to equal, I'm going to ignore the minus 3, to be honest. I quite like to just do it as a triangle. It is going to end up being negative. I'll go with 3 over 2, the opposite over the adjacent. And just make sure you're using radians here. That's typically what we do. So I'm not good at radians at the moment. Okay, 0.98279. Which means the arg of Z1. Now you've got different ways you can express the argument. You can go from 0 to 2 pi, or you can go 0 to pi and then 0 to minus pi that way. So I did the minus one. It doesn't actually specify, so you can choose and it will be implied by your answer. So I'm going with minus 0.8, no, sorry, 0.983. And then finally, we're not quite in modulus argument form. So I've got a component going horizontally, my 2, but it's actually going to be the modulus times by cos theta. So I will write down root 13. Just put a bracket in and then cos of minus 0.983. So that is actually this component here. And it will be plus I sine minus 0.983. I'm not going to be going to loads on where those components come from. This should be some, actually, I will. So if I call this the component x, then I can say that cos theta will equal x over the modulus of z1, the hypotenuse. Now I know x is actually 2, but we're trying to write this horizontal component in terms of theta and the modulus. That's what modulus argument form is. So that means in our case, x is going to be the modulus of the complex number times cos theta. So root 13 times cos of minus 0.983, which is what I had here. I then did the same for the opposite, and that's where I got the I sine of minus 0.983. So that is our modulus argument form. So in the answers, they abbreviate it to root 13 CIS of minus 0.983. That means exactly the same thing. It's just shorthand for it. You might even go for, if you've covered it, exponential form. So it becomes e to the minus 0.983i. But that is also, that could be something that comes later for you. Okay, so I'll leave this one here as my official answer. Part 2, we're asked to times the two complex numbers together in terms of A, writing our answer as C plus ID. So we're back to kind of this more Cartesian form. All right, so I'm going to get 2 minus 3i times A plus 4i. I've got these double brackets, so I've got 2a plus 8i minus 3ai, and then I'm getting minus 12i squared, which becomes plus 12. So then that will become 2a plus 12, that's my real component, plus 8 minus 3a I. Last two parts. So we're told that the real and imaginary parts of a complex number on the Argand diagram are x and y respectively, given that the point representing z1, z2 lies on the line y equals x, find the value of a. So that means it's going to lie somewhere along this line, which means that the real and imaginary parts are going to be the same. So we can say that 2a plus 12 must equal 8 minus 3a. It's got to solve that now. So 5a is going to equal minus 4. A is minus 4 over 5. Then given instead that the multiplication is equal to the multiplication with the complex conjugate taken, find the value of a. Right, so this time I've got my original 2a plus 12 plus 8 minus 3a. And we're told that this is equal to the complex conjugate, which is when you basically, sorry, that should have been an I, when you essentially make this part negative. So 2a plus 12 minus 8 minus 3a I. Just another example. So if we had 2 plus I, then the complex conjugate would be, put a little star there, would be 2 minus I. So immediately these cancel out. I can also cancel out the I. So it must be essentially that, well, this is equal to 0, in fact. That's the only way that can happen if a positive equals its negative. You might instead add 8 onto both sides and then add 3 onto both sides. But basically, you can just say that it must be that the imaginary part must equal 0. And therefore, 3a is equal to 8. So a is going to be 8 over 3.